Okay, so question 9. Triangle ABC, vertices, so on and so forth. Find the value of k. Okay, this is the x coordinate that we need to find. The information given is that these two have the same length. So quite clearly, what we need to do is to find out each of their lengths. Okay, so for AB, the length will just be the square root. Again, we're using Pythagoras over here. Check out the x and the y distances. Square them, add them, square root them. And we get the length of AB. So the horizontal distance will be 8 minus 0, we square it, plus the vertical distance of 14 minus 5, square it. This gives us 64 plus 81. So this is square root 145. We do the same thing for BC. Over here, to find this distance. Compare the x values. So k and 8. Bigger number minus a smaller number. Even if you take 8 minus k, it doesn't matter because you're going to square them eventually. So let's take k minus 8, square it, plus the difference of the y coordinates. 15 minus 14 is just 1. Okay? So we can either write 1 or put down in full. 15 minus 14, we square it. Here we get k minus 8 square plus 1. Now it is optional for you to expand this k minus 8 square, but I choose to leave it as it is first because subsequently, when we equate these two, you will see that it is more convenient to leave it in the square form. So since these two are the same, square root of k minus 8 square plus 1 must be equals to square root 145. Square both sides. Remove the square root, so we end up with k minus 8 square plus 1 is 145. And our objective is to find out the value of k. So anything that is outside of k, try and shift them to the other side by subtracting 1 on both sides, resulting in k minus 8, and we get 144. Now you should be happy to see a square equals to 144 because this tells us that k minus 8 must be plus minus of 12. So we have two values of k. But based on the diagram, we see that k is a positive value. It is on the right hand side of the y-axis. So when we find out the value of k, 8 minus 12, we get a negative. So we reject this. Or 8 plus 12, which is 20. This is our value of k. Okay? So we have established that this is 20. Now next, a line is drawn from B to meet the x-axis at D. These are examples of line from B to meet the x-axis at D. I don't know whether D is here, D here. There are so many possibilities. In fact, there are infinite possibilities. But they are restricting you with another condition. That is, AD is equal to CD. From A to D, whether it is over here, choose one of the lines that is reasonable, that has a length AD equals CD. Obviously, AD is much smaller than CD, isn't it? So you have to adjust the point D such that they're generally looking like the same. For example, this point. Okay. Now, what is this shape? What is this shape? Yes, it is a kite, where two of the adjacent sides have the same length. The other two adjacent sides have the same length. So this is a kite. What are some properties of the kite? Tell me about the diagonals. AC and BD. Yeah, they are perpendicular to each other. In addition, A to the midpoint, to the point of intersection, and the intersection to point C, these two have the same length. Okay, one of the diagonal bisects the other diagonal. So these are the properties of a kite. This is one approach that we can use to solve for the equation of BD, and subsequently to find the coordinates of D, because we can very easily get a gradient of AC. Once we have the gradient of AC, using these two sets of coordinates, we take the reciprocal, we multiply by -1, we get a gradient of BD. once we have the gradient of BD with one set of coordinate, I can find the equation of BD. And that is the approach given by the work solution. Once I have the equation of BD, I can find the coordinates of D because D has y coordinates equals to 0. So that is one approach. Okay? The other approach is by considering these two have the same length. That means we are actually doing something very similar to what we did in part 1. We find the length of AD, we set D to have an x coordinate of, for example, n. Y coordinate is 0. So same thing, we find the vertical height, horizontal height, square them, add them, take the square root. So we have an unknown on the left hand side with n. We do the same thing for CD. Vertical height, horizontal height, one equation, one unknown, you can solve for n. Once you have the value of n, once you have this coordinate, we can find the gradient of this line and find the equation. So in this second approach, we will be finding coordinates of D first. Then we find the equation of BD. The question didn't say what you need to find first. So both ways will be acceptable. Any questions? Next, to show area of triangle ABC is 2 over 7 of ABCD. Okay. So right now let us put in all the coordinates that we have. These coordinates are 15, 0. Okay, so from here we will need to use our shoelace method. First we find our area of ABC. Area of ABC, half, draw a vertical line, choose one set of coordinates. For example, 20, 15. Put a 20, put a 15. Do we go clockwise or anti-clockwise? Anti-clockwise, huh? If you go clockwise, what will you get? Yeah, you will get negative area. So you are supposed to go anti-clockwise to get a positive area. So anti-clockwise, the next point will be 8, 14. X coordinate on top, Y coordinate below. Go anti-clockwise again, 0, 5. We should be happy to see any of the coordinates equal to 0 because then we multiply, it will still be 0, okay? Now, we still need to close the loop. For a triangle, we will be writing 4 sets of coordinates because we must end back at the original point. Okay, so these two will be a repeat. Now next, we will be going downwards. Multiply all these. 20 and 14 plus 8, 5. 0 times 15, don't bother writing down. Close the bracket, minus. Now inside this square bracket, we are going to be adding. But for multiplication, for products in the other direction, 8 and 15. 0 and 14, don't bother. 20 and 5. So all these will be multiplied by half. Don't forget the half over here. So use your calculator. 280 plus 40 minus 100. So we get a total of 50. Okay, because we have to divide by 2. So that is the area of the triangle. Now we move on to the area of ABCD. Similar steps, but okay, let me just write down the coordinates for you. 20, 15. Next, 8, 14. 0, 5. 15, 0. And back to 20, 15. So similar steps, you will get 175 if I didn't remember wrongly. Yep. So now our area of ABCD is 175. So what this means is that area ABC over area ABCD is 50 over 175. simplify it with your calculator, and that's 2 over 7. What this means is that area ABC is 2 over 7 of ABCD, and this is shown. Okay? Any questions for this? Do we have to write down the last line? This part. What if you only show that it is 2 over 7? Okay, I still need this line over here. Because they ask you specifically show area of triangle will be equal 2 over 7 times area of ABCD. So we need to show the last part. Okay? Right, next question that I want to talk about is question 5. Over here. Specifically for part 2. Okay? In order to solve the equation x equals to ln root 9 minus x, a graph of a suitable straight line is drawn on the same axis as a graph of y equals to 5 minus e power 2x. Now this graph of y equals to 5 minus e power 2x is already, is assumed to have already been drawn. So we're going to combine these two graphs together in order to solve this equation. Okay? Now, I will illustrate with a simpler case first. Suppose we are doing simultaneous equation. Okay? First equation is y equals to 3x plus 5. Second equation, y equals to x squared plus 4. Solve these two equations. How will you do it? Sub 1 into 2, right? Or 2 into 1, doesn't matter. Sub into 1. Okay, so we end up with x squared plus 4 equals to 3x plus 5. Then since this is quadratic, we're going to put everything to the left hand side, minus 3x minus 1 equals to 0. Okay, so this is our equation number 3, which we have to solve over here. And then you move on, whether this actually gives us roots or not, we have to find out. Minus b plus minus square root b squared minus 4ac over 2a, and you get the corresponding y value. This is how we do it, right? Now what if the question is changed? The question says that plot y equals to x squared plus 4. Okay, can we do this? Plot y equals x squared plus 4. Is it difficult? No, it's simple. Table, x, y, plot everything out. Then the next part of the question says, by drawing a suitable straight line, or maybe they don't even say suitable straight line, they say by drawing a suitable graph on the same axis as your y equals to x squared plus 4, solve the equation, and this is the equation they want you to solve. X squared minus 3x minus 1 equals to 0. How should we proceed to determine a straight line such that when it is drawn together with y equals to x squared plus 4, allows us to solve this equation? Remember, this is equation number 3. I am showing you the relationship between these two questions. Okay, think about it. How do we determine the graph to be drawn? Looking at the left hand side, I know that the graph I have to draw is this, right? Because there's a simultaneous equation. How am I supposed to get from equation 3 back to equation 1? That is our goal. So look through the steps again. How do we arrive at equation 3 from equation 1 and 2? And think about how we go backwards. Okay, so now equation 3 is actually a combination of equation 1 and 2. Do you agree? It's a combination of 1 and 2. That's what we mean by simultaneous equations. So right now our job is to, from equation 3, we extract equation 2. We try to work backwards from equation 3, the previous step. We actually obtain the right hand side of equation 2. As long as I can extract a part of the given equation, then the other side must be the graph that I need to draw. Okay, so let's see how this works. From here, I want to extract what I've already plotted out. What I have plotted says x squared plus 4. From the equation I have to solve, I've got x squared also. But I've got minus 3x minus 1 equals to 0. So to make them the same, we keep the x squared, shift everything to the right, 3x plus 1. Notice that I only manipulated the equation that they gave us, that we are supposed to solve. Okay, nothing fanciful over here. Now it is getting to be similar to what I already have in my graph. I've got the x squared. But what is the difference? There's a plus 4 over here. So next step, x squared plus 4. If I add 4 to this side, I must also add 4 over here. 3x plus 1 plus 4, which is 3x plus 5. So right now I see that, hey, I have the left hand side of I have the right hand side of the graph that I've already plotted, which is x squared plus 4. This is equal to y. Y equals to x squared plus 4. At the same time, y is equals to 3x plus 5 because of all these equal signs. So this must be the other graph I need to plot. Plot y equals to 3x plus 5. And here we have our equation 1 over here. You understand how we are working backwards now? Let's try that for question 5. Question 5, we are given y5 minus e power 2x. You can treat this our equation number 1. We are supposed to use this and we plot another equation 2. This is a question mark, such that when we solve them simultaneously, we will get equation number 3, which is x equals to ln root 9 minus x. This is our equation 3, after we solve 1 and 2 together simultaneously. Okay? So recall, my approach was to extract whatever was available from my equation number 3. Do they look similar? At the moment, 1 and 3, they don't look similar, right? Equation 1 has e to the power of something. Equation 3 has ln. So how do we make equation 3 look like equation number 1? That means I don't want the ln already. I want e to appear. That means we are converting from ln to exponential form. You have to remember how to convert your log form to exponential form and vice versa. Okay, so based on this is actually x equals to log base e root 9 minus x. This is from equation number 3. So the base is e. E, the power is x. Power x equals to square root 9 minus x. Is it starting to look like equation number 1? At least my ln has disappeared, right? And the e has appeared. Okay. I've got e power 2x over here. It's with a negative sign. There are many ways we can start with this question. Yes? You can also choose to manipulate the square root, because in equation number 1 there is no square root. So how do we get rid of this square root? Square both sides. Get rid of the square root by squaring both sides. So when you square ex, you square this, you actually get e power 2x. So this is e power 2x. On the right hand side, 9 minus x. Now it is starting to look more like it. Now I want a negative sign in front of e. How do I do that? You can put it to the other side, then 9 minus x, bring it to the other side, or you can just choose to multiply everything by negative 1. So we have negative e power 2x equals to x minus 9. I've got a negative e power 2x now. But what's missing on the left hand side? I need to plus 5. I need to add a 5 over here, means I need to add a 5 over here. So here we get exactly 5 minus e power 2x equals to x minus 4. Alright, minus 4, negative 9 plus 5. And we see that we are already given y equals to 5 minus e power 2x. So equal, equal, equal. The other equation must be plot y equals to x minus 4. And the intersection point between this equation number 2 and equation number 1 will give us the solution to equation number 3. Okay? This is the approach for this type of question. Take note that this skill is very important because you will be tested on this skill in E-maths also. Now in this particular A-maths paper, they did not ask you to actually plot it out. They did not ask you to plot it out and read from the graph. In E-maths, you will be asked to actually plot it out and read from your graph the values of the x coordinates. Okay, and please take note, when that happens, we only want the x coordinates. We don't want the y coordinates because they're asking for solutions to equation number 3 in E-maths. Okay? Okay, so this is our A-maths 2010 paper 2. With the remaining 5 minutes, I've looked through the work that you guys have submitted for 2010 paper 1. There are some common issues that I want to go through first. Question 3. Question 3 part 2. It says solve 3x squared minus 5 greater than x minus 1. This is a quadratic inequality. Okay, I will skip the intermediate steps. This is what we should arrive at. (3x squared minus x minus 14 greater than 0). The next step, after you factorize, 3x minus 7, x plus 2 greater than 0. And for some reason, somehow, you are able to, from this step, tell me that you obtain this number line. My question is, how do you know it is the region to the left of -2 and the region to the right of 7/3? More than 0 shade upwards. Why would you have that impression? Because y-axis is... Okay, for those of you who are following what Cosby is saying, that is, you think the same way as him, you are actually making an assumption. Okay, if you have the same thought as him, you are making an assumption. Your assumption is that the coefficient of x squared is always greater than 0. Okay, you can make it that way. You have the means to make the coefficient of x squared greater than 0 by multiplying everything by a -1 should the coefficient be negative. Okay? Then when you do that, the inequality sign will flip. You can do that. And then you follow his method, everything that is greater than 0 is above, everything that's less than 0 is below. Yeah, okay, you will be able to get the same answer. But I would really want you to know the reason why this happens. The reason why this happens is because of the quadratic curve. Yes, it's a parabola. It is a parabola, either opening upwards or downwards. Based on this case, this question over here, we have a parabola opening upwards because the coefficient of x squared is positive. So we are expecting a parabola that looks like this. Okay? Now, they say they want the region where it is greater than 0. They want this portion. Now, this portion is everywhere on the curve that they have drawn up. They want the region of the curve is greater than 0, which means only this portion, because it stretches to all the way up, so we are actually talking about everywhere to the left of -2, and this portion, which corresponds to everywhere to the right of 7/3. So these are the two regions that we want. In the event that the question states, after you factorize, you get 3x minus 7 x plus 2 less than 0, then your graph will look like this. Same graph, but we want the region that is less than 0. Over here. So here's the next part that he just mentioned, which is the next type of question you hardly see, but it can come out. What if our questions is like this? Negative 3x squared plus x plus 14 greater than 0. What if you have this as the inequality? And after you factorize, this is what you will get. 3x minus 7, x plus 2 with a negative and a positive over here, greater than 0. Okay? So our graph now, the intersection point doesn't change. It is still negative 2 and 7 over 3. Right? Based on this, the intersection, the x-intercept is still negative 2 and 7 over 3. Well, what does your curve look like? Parabola opening up or down? Now it is a parabola opening downwards. Since it is a parabola opening downwards, and I want the region greater than 0. I want the region of the graph that is greater than 0. Now it is going to be this part. And in this case, our required range is from negative 2 to 7 over 3. Okay? Now, Cosby, do you see the difference? Although it is a greater than 0 here, it is a greater than 0 here. In the first case, we have the region x less than negative 2, x greater than 7 over 3. And in the second case, although it is still greater than 0, we have the region from negative 2 until 7 over 3. Okay? So without drawing a graph, I don't see how you are able to get the required range just like that. Unless you have already by default, every time you will change the coefficient of x squared to a positive. Unless that is your default method. Always change it to positive coefficient. Then depending on how the inequality sign changes, you determine whether it is the range outside or the included range inside. Okay? No, it is okay to multiply by negative. But even if you do that, you should also sketch the graph so that there is meaning behind your working. Okay? So that's all for today's lesson, one period, very short.